Welcome to the DIY Honda Garage channel. This presentation addresses the Diagnostic Trouble Code DTC P2120-1C, specifically relating to the accelerator pedal position APP sensor A, which monitors the throttle position TP sensor D. In vehicles like the 2023 Honda CR-V, if the output voltage from the APP sensor A falls outside the designated range, the Powertrain Control Module, PCM, will detect this anomaly and record the DTC. The APP sensor is crucial as it provides real-time data on the accelerator pedal's position, which the engine control system uses to regulate power delivery and maintain optimal engine performance. This malfunction can lead to undesirable engine behavior, such as poor acceleration or difficulty in maintaining speed. Therefore, accurate troubleshooting is essential for ensuring the vehicle's operational safety and efficiency. The accelerator pedal position sensor A plays a vital role in measuring the pedal's position to determine the engine's throttle response. This sensor is integrated within the accelerator pedal module located near the driver's footwell, making it easily accessible during diagnostics. The sensor communicates its readings to the Powertrain Control Module, PCM, to adjust engine functions accurately. If the APP sensor A's voltage is outside the acceptable range, ideally between 0.88 to 4.82 volts, the PCM interprets this as a malfunction, leading to the DTC being stored. Understanding the APP sensor's position and operation is key in diagnosing and resolving the issue flagged by this DTC. Other related components include the VCC1, power supply, APS1, signal, and SG1, ground, which work in unison to facilitate the vehicle's electronic throttle control. When diagnosing DTC P2120-1C, several potential causes must be considered. One primary issue could be the output voltage from the APP sensor A, which may be inaccurately reading less than 0.88 volts or more than 4.82 volts due to sensor wear or malfunction. Another factor could be wiring issues in the circuit connecting the sensor to the PCM. This could include open circuits, short circuits, or resistance issues that may lead to incorrect voltage readings. Lastly, the Powertrain Control Module, PCM, itself could be faulty, especially if other components test normal. Effective diagnosis requires careful inspection of these elements to determine the root cause of the DTC and proceed with appropriate repairs. When DTC P2120-1C is triggered, the driver may experience several noticeable symptoms. The most prominent symptom is poor acceleration performance, which occurs when the vehicle is unable to respond adequately to accelerator inputs. This can make driving unsafe, especially when quick speed adjustments are necessary. Additionally, the throttle response may be inconsistent, resulting in an erratic driving experience. Drivers may also notice warning lights on the dashboard, indicating that there is a problem that needs to be addressed, prompting a visit to a service center. Furthermore, the vehicle's efficiency may decline, and fuel consumption could increase due to improper engine management, further hinting at issues stemming from the APP sensor or related components. The first step in troubleshooting DTC P2120-1C involves turning the vehicle to the on mode. This positioning is essential to engage the vehicle's electrical systems without starting the engine, allowing for accurate diagnostics. Once in the on mode, using the Honda Diagnostic System, HDS, check the APP sensor A voltage. The system should provide feedback on the sensor's voltage reading. If the voltage is found to be either less than 0.88 volts or more than 4.82 volts, this confirms that there is a repeatable instability in the sensor output, indicating that the failure is duplicated. Documenting these readings will help in pushing forward with further diagnostic steps. In step 2 of the troubleshooting process, it is crucial to measure the APP sensor's output. Begin by disconnecting the APP sensor's connector. Then, using a jumper wire, connect terminals number 4 and number 6 on the sensor connector. This action simulates the sensor's operation and is essential for accurately diagnosing the sensor's condition. After connecting the jumper wire, again, turn the vehicle to the on mode. Observe the HDS for the APP sensor A voltage. It should now be more than 8.88 volts for the component to be deemed functioning correctly. If the reading falls outside of this range, it identifies an issue with the accelerator pedal module itself, necessitating further inspection or replacement of that component. For step 3, focus shifts toward inspecting the circuit wiring connected to the APP sensor. Begin by ensuring the APP sensor connector remains disconnected, as well as the PCM connector A. This precaution helps to avoid any electrical interference during testing. The next phases involve checking the VCC1, APS1, and SG1 circuits for continuity and proper voltage readings. Normal conditions require less than 1 ohm of resistance in these circuits when the vehicle is off. If issues are detected within this wiring, it means there is a breakdown in the specific circuit leading to incorrect or no signals reaching the PCM. Addressing these problems can greatly affect the overall functionality of the throttle control system. In step 4, the emphasis is on inspecting the integrity of the wiring through an open, shorted wire inspection. With the APP sensor and PCM connectors still disconnected, perform measurements to verify the condition of the circuits. The goal is to identify whether there are any open circuits causing the APP sensor to malfunction. This involves checking VCC1 for signs of an open wire in the power supply circuit, ensuring there's less than 1 ohm of resistance. Similarly, inspect APS1 and SG1 circuits, looking for their respective resistances. Should any significant deviations be noted, such as open circuits or shorted connections, these issues must be resolved to restore proper function. Accurate wire inspection is key to diagnosing DTC issues effectively. Step 5 in the troubleshooting process involves conducting a thorough inspection of the powertrain control module, PCM. After determining that all other inspection items indicated normal conditions, you can infer that the PCM is the likely cause of the problem. This assessment should be backed by the previous circuit and wiring checks, which, if they all proved fine, would point towards the PCM's failure. A PCM is critical as it is responsible for processing signals from various engine components and responding accordingly. Repair or replacement of the PCM may be required if found defective during the examination. Each step leads progressively toward isolating component failures, with the PCM being the final checkpoint if all other parts test as functioning. To verify the effectiveness of repairs after addressing DTC P2120-1C, conducting a final test drive of the vehicle is essential. This not only assesses the functionality of the accelerator pedal and throttle, but also ensures that the repairs made have fully rectified the initial problem. During the test drive, attention should be given to throttle response, ensuring acceleration behaves consistently without lag or abnormal behavior. After completing the drive, utilize the Auto Diagnostics system to confirm that the DTC has been cleared successfully. If the code reappears, this indicates that further investigation is necessary. Successful verification means the vehicle can now operate within safe parameters, ensuring optimal performance. To mitigate the chances of encountering DTC P2120-1C in the future, implementing preventive maintenance practices is vital. Routine checks of the accelerator pedal position sensor should be conducted as part of a regular vehicle maintenance schedule. This helps in identifying any early signs of wear or signal discrepancies that could later lead to DTC triggers. In addition to sensor checks, it's essential to keep the area around the pedals free from debris or obstructions. Such practices ensure that the sensor can operate effectively without physical interference, thus maintaining its accuracy. Regular maintenance plays a crucial role in enhancing the vehicle's reliability and performance, keeping unexpected issues at bay. In summary, addressing DTC P2120-1 involves recognizing the crucial role of the accelerator pedal position sensor A and associated wiring within the vehicle's performance system. Proper troubleshooting steps include evaluating the sensor's output voltage, inspecting circuit integrity, and verifying the condition of the PCM. Recognizing the symptoms experienced while driving can lead to timely diagnostics and repairs, thereby enhancing the vehicle's safety and performance. Additionally, adopting preventive maintenance practices further aids in prolonging the lifespan of these components. Accurate diagnostics not only rectify existing issues, but also contribute to the overall efficiency and reliability of the vehicle, facilitating a smoother driving experience. Remember, regular monitoring can be your best defense in avoiding complex repairs in the future. Please like and subscribe to the channel. See you next time.